I'm on spring break, and we just had a test, so I was thinking I could get ahead on some stuff.
Okay.
So it's called Recursive Rules of Sequences.
Okay.
Um,
I can help you a little bit with that. Have you begun arithmetic sequences yet?
yeah,
Okay. Have you begun geometric sequences?
yes.
Okay. Well, you want to talk about both of those?
Sure.
Let's just discuss them briefly. Arithmetic. What's the nth term equal to?
The number you're trying to find in the sequence.
Well, yes, but there is a general formula for it.
Oh, right. A sub n equals A sub 1. Let's see. Plus n minus 1 times the common difference.
Right. Okay. Now, as long as we're talking about it, let's put the geometric up there also.
All right.
Probably want to memorize these. These are important enough that you want to know what they are. There's the arithmetic. Okay. Now, these are the explicit definitions of them. Recursive, by definition, means that the nth term is in terms of the nth minus 1 term. So if I want the recursive definition of an arithmetic series, then it's going to be what? It's going to be the previous term. You think about an arithmetic sequence. Let's look at this sequence over here. So if this is the nth term, and this is the nth minus 1 term, what's the difference between them?
3.
So it's plus the common difference. In other words, that is the recursive definition for an arithmetic sequence.
Okay.
For the geometric, the recursive definition would be what? Remember, it's always related to n minus 1 term.
Times the common, wait.
Yep, you got it. Times the common ratio. In other words, a geometric sequence might be this. So this term right here is the previous term times the common ratio.
Okay.
Okay? That's really all you need to understand about the recursive definition. Now, obviously, the one that's not easier, but used more frequently is the first one, the general one, this one here. The reason is that you usually know the first term and the common difference. You don't always know the nth minus 1 term.
Right.
Or the term sub n minus 1. So I'm not real clear as to why math goes out of its way to even teach you the recursive definition. And they certainly can give you problems where you're required to know this. But I don't know, there might be some higher math that uses this. The ones that I would memorize are those. The explicit definition as opposed to recursive. Now, do you have any problems, specific problems you can give me?
Yes.
Okay.
Let's see. All right, so for this one, we have to write the first 5 terms of the sequence, and it gives us a sub 0 equals 1, and also a sub n equals a sub n minus 1 plus 4.
So this looks like it's going to be an arithmetic sequence.
Okay, yeah.
Right? Because it fits this definition here. It does not fit this definition here. It's got a plus 4. That's going to be plus D. Okay? First of all, let's get our terminology straight. A sub 0 is the first term?
It gives us a sub 0 equals 1.
Right. But by definition, a sub 0 means, shouldn't that be a sub 1, first term?
It just gives us that in addition to the...
I know, but if we look at our definitions, we're using a sub 1.
Yeah.
And there is a difference between a sub 0 and a sub 1. A sub 0 would be the 0th term, which doesn't really exist. So I think it's important to use a sub 1 in our terminology and our definition. A sub 1 is the first term of the sequence. I believe that's what they mean when they say a sub 0. I don't know why they call it a sub 0 is my only confusion.
Yeah, because there's other problems with a sub 1, so I don't know.
Really? And yet this one has a sub 0.
Yeah.
Okay, well, based on the recursive definition, what is D?
4.
Okay, so now we can write the explicit definition. We know a sub 1 is 1. We know what D is. So now I can simplify that. Usually you can always simplify the explicit definition. Notice we're going to be able to combine the number part.
Okay.
So that's what a sub n is. Is that what they're looking for, is what a sub n is? Or they want the exact sequence?
They said they want the first 5 terms.
Okay, so what's first term?
First term is 1.
Exactly. Second term? There's the common difference right there.
It's 5. I was overthinking it.
Third term, yeah. These are actually
9.
pretty easy, but
Yeah.
it's 9. It's fourth
And then
term.
13 and 17.
There's the first 5 terms. But notice, they gave us the recursive definition. So we had to look at this to figure out that from what they gave us, 4 is D. And they also gave us a sub 1, so they gave us everything we needed to write the explicit definition. And from the explicit definition, I guess we really don't need the explicit definition. Once we know a sub 1, in other words, they give us this term, and we know that D is 4. So we can write the first 5 terms from that information alone.
Right.
Didn't really need to solve it for the explicit definition. Okay, what's another one? I'm going to leave all that information up there because it's going to be useful.
Okay, I have, let's see, a sub 1 equals 10, and then a sub n equals 3a sub n minus 1.
Like that?
Yes.
Really? That's it.
Yep.
Do we know if it's an arithmetic sequence or if it is a, what's it look like? Based on our two recursive definitions. Does it look like arithmetic or geometric?
It looks like geometric.
Does. It fits that, right?
Yeah.
In other words, it's a multiplier. So what is R?
0.
No? R multiplies a sub n minus 1.
So R would be 1.
Multiplies a sub n minus 1. So 3 is the common ratio.
Okay.
And if they want the first 5 terms, same thing.
All right.
What do they want?
Yeah, they want the first 5.
Give them to me.
Okay, so let's see. It'd be 10, then 13.
This is a geometric ratio. We're multiplying.
Oh, so 30, and then 90, and then 270, and then
That's what
810.
Okay. So the pattern is the same. They're giving us the recursive definition in each of the last 2 problems, and that's enough to figure out what either R or D is. And once you have R or D, depending on whether it's geometric or arithmetic, you can accomplish the task. What else you got?
This next part says to write a recursive rule for the sequence. And then it says the sequence can be arithmetic, geometric, or neither.
Okay.
All right, so the first one is 1, 7, 13, 19, and then it goes on from there with 3 dots.
What is that? Is that arithmetic, geometric, or neither?
That looks like arithmetic.
Okay. And what do they want? The recursive definition?
Yeah.
Okay. So what's it going to be? A sub n is going to be equal to what? In other words, we want to go up to that one right there.
Okay, so that'll equal a sub 1 minus 1.
Hold on. Is a sub n minus 1
Okay.
plus d.
Plus 6, yeah.
That's it. There's your answer.
Okay, that's easy.
I should use the same. This should be little a. I don't mean to use capital A and little a to mean different things there. About another one.
Okay,
You can see that these are pretty easy as long as you know those formulas, those 4 formulas there.
yeah.
Just plugging them in. What's the next sequence?
66, 33, 16.5, and then 8.25.
What kind of sequence is that?
Is it geometric?
It is. What is R?
Is it 2? No, 1/2.
1/2, 0.5. Okay. And what did they want? The recursive?
Yeah.
Okay, so we're going to use this one. So a sub n is equal to what?
To a sub n minus 1
Times
0.5.
Yeah, I'm going to kind of do it the way they did it, which is to put my number in front.
Okay.
Matches the way they gave it, the last problem to you where they gave it as 3, and they had the 3 in front. And it also makes sense. It can be a little confusing if I put that 0.5 to the right of a sub n minus 1. We want to treat it like a coefficient, so we want to put it in front. Okay, what else you got?
Okay. 6 and 6 to the square root of 2 and 12.
Like that?
And, yeah. Or no. It's just 6 times the square root of 2. That's my bad. And then 12. And then 12 times the square root of 2.
What kind of sequence is this?
Geometric?
Correct.
Okay.
And really, there's an easy way to tell. Okay? First of all, you take your second term minus your first term. If that's the same number as your third term minus your second term, it's arithmetic. Right?
Right.
If it's geometric, you take your second term divided by your first term. If that is the same number as your third term divided by your second term, then it's geometric. Well,
Okay.
it certainly is not arithmetic.
Right.
So it's either geometric or it's something else. And trust me, there are a lot more sequences that are something else than arithmetic or geometric. Okay?
Okay.
So these are two very unique types of sequences. So if I jump to the conclusion that it is geometric, how do I figure out what R is?
Divide the second term by the first term.
Okay. What is that answer?
Square root of 2.
Okay, now let's see if that's what R is. So we're saying R is square root of 2. What happens when you multiply the second term by square root of 2? What do you get? Should give you the third term, right?
Yeah.
Does it?
It does.
Huh. Now if I multiply the third term by square root of 2, what does it give me?
12 times square root of 2.
So we definitely are looking at a geometric sequence here. What do they want? The recursive definition?
Yes.
Okay, what is it?
It is square root of 2 times n minus 1.
A sub n minus 1. Remember, the recursive definition, regardless of whether it's arithmetic or geometric, always is going to have an a sub n minus 1 in it. In other words, the recursive definition is always based on the previous term. If you're looking for the nth term, it's based on the nth minus 1 term, which is the previous term, right?
Right.
Always. So the only thing you need to do is have the n minus 1 term and multiplied by the common ratio. Okay. What else? It's going to get a little bit harder. Usually they'll give you like the second and the fourth term, and they'll say, give me the sequence or the explicit definition. And then you end up with 2 equations and 2 unknowns, and you have to solve a system of equations. That's about as hard as they get, but
Okay.
translating between explicit and recursive is relatively simple, as you can see. Both types both definitions are very similar. They both have D in them or R in them.
Right. Okay. So this next part is writing rules. So it says to write an explicit rule and a recursive rule for the sequence.
Go ahead.
All right. So the first one gives us a sub 1 equals 2 and r equals 10.
So what kind of sequence is this?
This is geometric.
Okay. Give me the explicit.
A sub n equals 2 times 10 to the n minus 1.
What's the recursive?
That's a sub n equals a sub n minus 1 times 10.
Yeah, and it's fine to write it like that. That you won't lose any points by putting the 10 afterward. Okay? You can see these are pretty easy, really. It's just, as long as you know those 4 formulas, you just plug in. That's so far, every single problem we've had, that's what we've had to do.
Right.
What else?
Let's see. Okay. I'm trying to find one that looks hard.
Yeah, if you can find one where they don't give you a sub 1, those tend to be hard. Because you can see that our explicit formulas all start with a sub 1.
Right. Let's see.
Usually they'll give you a sub 2 or a sub 5, or both of those, and then they'll say figure out the sequence.
Okay.
They won't give you a sub 1. If you start with a sub 1, it's going to be a pretty easy problem.
Yeah, all of them give me a sub 1.
Okay. Let me give you one.
Okay.
Say geometric sequence. And I do have to specify, because I'm sure I could figure out an arithmetic sequence for that also.
Okay.
So if I'm going to give you 2 of the A's, subs, then I have to specify whether it's geometric or arithmetic. So this is geometric. The second one is 3. The fourth term is 81. What's our sequence and what's the explicit formula for it?
So the formula would be a sub n equals a sub 1. Wait, so would the first number in the sequence be 1?
Well, I made it too easy. In other words, you're smart enough that you can figure out what this sequence is, because I made it up off the top of my head. So I made it easy. But let's do it the proper way.
Okay.
It's a geometric sequence, so it has to abide by that. And we're told that a sub 2 is 3. So 3 has to equal a sub 1. And yeah, we don't know yet what the common ratio is, but we know it's the second term. So I've got that, right?
Right.
And I can also say that the fourth term is also a sub 1, which I don't know yet, times common ratio to the 4 minus 1. So what that gives us, going here in the upper right, is 3 equals a sub 1 times r, and 81 equals a sub 1 r to the third.
Right.
Okay. So what do we have? 2 equations, 2 unknowns, a sub 1 and r. So we're going to have to solve this as a system of equations. Okay. So let's just solve it. How would we solve those two?
Um,
I hope you've memorized these, because if you're going to memorize something, you're never going to memorize it if you're always looking at it. So how do I solve those two systems of equations? Solve the first one for a sub 1.
Okay. So would I divide?
Right?
Yeah.
Okay. Now substitute. Use substitution. So in place of a sub 1 in the second one, I'm going to substitute 3 over r.
Okay.
Now solve that.
So that equals
In other words, r cubed divided by r is r squared.
okay, there. Yeah. And then divide by 3 on both sides.
Hold on a minute. I made a mistake here. No, I didn't. No, I didn't. No, everything's right. Yeah, divide by 3. So you get 27 equals r squared.
And then take the square roots.
Which is 3 root 3, which I don't think is right. I meant for r to be 3. Where did I go wrong here? Hold on a second. Let's see. A sub n, which is the second term, equals the first term times the common ratio to the n minus 1, which is 1. So this equation's correct. A sub 4, which is 81, is equal to a sub 1 times r to the 4 minus 1. So this equation is correct. Why am I not getting the right answer? R, we know, is 3, right? In other words, I pulled the sequence. I made it really hard. No, I did not do it correctly. I didn't even multiply it in my head correctly. That was the sequence I was intending, but I gave you the wrong a sub 4. A sub 4 is 27.
Oh.
Notice that we've discovered the problem because r didn't come out to be correct.
Right.
Had I made that 27 like I intended, now we solve it, and that comes out to be 9. Square root of 9 is 3. So we do solve for r if I'd have written it down properly.
Okay, that makes
But
sense.
it kind of tells you two things. It tells you that when you solve a problem and you get an answer that doesn't match the problem, something's wrong. And what was wrong was my a sub 4. It wasn't 81, it was 27. This was the sequence I was thinking of. The sequence I actually gave you? It's interesting. What would that be? I guess you could figure it out, yeah. I mean, you can have a sequence like that, and R would have been 3 root 3. That would have been a different sequence. It wasn't really the one I was thinking of. So that's the hard ones, when they give you not the first term, but some nth term and then another nth term. Because that always means you're going to have to use 2 equations and then solve a system of equations, like I had to solve that.
Okay.
Okay. Jake, you got any other questions?
No, I'm good for now. Thank you.
Okay. I will talk to you next Monday.
All right. Thank you.
Bye-bye.